Hi there and welcome to another video from HEGARTYMATHS. It's Mr. Hegarty here, and in this video we're talking about integration, and in particular integration by inspection. So in this video we'd like to integrate functions by inspection of the form f-x f of x to the power of n. For example, say my f of x was something like x squared add 1 and I was raising this to the power of, 10. F-x would be 2x. So it would be functions of this form. These are the type of functions I would like to be able to integrate. So where you've got some function of x to a power and that expression inside the brackets differentiated and multiplied by the expression to a power. So we like to integrate functions like that, and we can do it by inspection. Now, in order to get there, let's talk about some standard differentiation results. Okay, so let's do a few examples. Suppose I had y is equal to, 5x cubed, and I was to differentiate that. We know that dy by dx would be equal to 15x squared, okay? So, if I originally gave you this function, if I was asking you to integrate 15x squared with respect to x, okay, what would the answer be? Well, I'd undo the process. I'd think about what function differentiated to that. I know it must have come from an x cubed, because when I differentiate x cubed, I get 3x squared. And I know it must have a 5 in front of it, so that the 3 multiplied by 5 gives me the 15, and plus a constant. Okay, so this is the idea we're going to use. Let's take this one step further. Suppose I had y is equal to 5x plus 2 cubed. What's dy by dx? Well, I would multiply by the 3, I would multiply by the differential of the bracket 5, I would keep the bracket as it is, and I would reduce it by a power of 2. So this would give me the answer 15 5x add 2 squared. So that would be my dy by dx. Okay, now, if I asked you, without knowing what I've just done, if I asked you what the integral of 15 5x plus 2 squared was with respect to x, you would have to say, well, it must have come from a 5x plus 2 cubed. Because when I differentiate 5x plus 2 cubed, I multiply by the 3, multiply by the 5, and keep this 5x plus 2 squared, which would sort me out with this thing. So multiplying by the 3, multiplying by the 5 would give me this 15 that I'm looking for, and so that would be my answer plus c. Okay, now let's try one more, slightly more complicated one. What about if I gave you the function y is equal to x squared add 2x add 3 all to the power of 7, and I asked you to differentiate this? What would dy by dx be? Well, you'd multiply by the 7, and then what you do is you differentiate inside the bracket, so you get 2x add 2. Then what you do is you keep the bracket as it was, x squared add 2x add 3, and you reduce it by a power of 1, so it'd be to the 6. Okay, now, say if I asked you to integrate this thing here, a 7, 2x add 2, x squared add 2x add 3, with respect to the 6 with respect to x, you know that the answer, undoing this process, must be x squared add 2x add 3 to the power of 7 plus c. Now, how would I have got there if I hadn't have done this? Well, looking at this here, I must think that in order to get that in as part of my answer, maybe the thing I differentiated was x squared add 2x add 3 to the 7. Because when I differentiate something like that, I bring down the 7, hence that came there. I would differentiate the bracket, hence I'd get that. And I would reduce the power by 1, hence I'd get that. So these are the type of functions we want to integrate. So this is the thing we're trying to integrate. We're trying to integrate things that look like this. The integral, you've got the differential here, and you've got a function of x to some power of x. Okay, these are the type of things we're trying to differentiate. So you can see here that we have an f of x to some power, and we've got the differential of the bracket there. We'll forget about the number for now. Something of that form. In fact, I could just put a number there like a. And what I'm always going to try, I'm going to try for integrals like this, I'm going to try to let y equal f of x to one more power to an n plus 1 as the answer. I'm going to differentiate this thing and check if it equals the thing inside the brackets. So that, i.e., the integral of the thing inside the brackets would give me this as my answer. Okay, so the result we're going to try and use, like I said, so if I'm integrating, these are the type of things we're trying to do. If you're integrating some number multiplied by f dashed x and f of x to the power of n with respect to x, we're going to try as the answer y is equal to f of x to the power of n plus 1. We're going to try that, but we may need to make an adjustment. I'm going to put in brackets here, plus make adjustment. So these are the sort of things we're looking out for. If we see anything of this type of form here, then we're going to think integration by inspection and try this answer. So let's give it a go with a few examples. We're integrating 3 cos x sine x squared. So actually I'm just going to rewrite that in the following way. This might help us. 3 cosine x sine x all squared with respect to x. Now this does look of the form that I was talking about. Remember the form I was talking about? I was saying f dashed x, f of x to the power of n. It's got some function of x to the power of n, and the thing outside that power looks like the differential of the original function, okay? So let's try y is equal to sine x cubed as our answer and see if that works. If we were to differentiate this, if this was our answer and we differentiate this and we get that, we know this is the answer. So dy by dx in this case, well, what would it be? You would multiply by the 3, you would differentiate sine, and you would get cosine, and you would keep this, but to one less power, so sine x squared. So it would be 3 cosine x sine squared x. So given that if we differentiate this function, we get this, therefore, when we integrate this function, we must get that back. So therefore, by inspection, the integral of 3 cosine x sine squared x with respect to x must be this here, sine cubed x, but plus a constant. So just to reiterate, we've just tried this as the thing we differentiate. So what we've done is we've differentiated there, and we found that when we differentiate this function, it gives us the exact integrand we're looking for. So therefore, the thing we're trying to integrate, if we integrate that, we know it must be this function we tried as the answer, but plus a constant of integration. Okay, let's give another one a go. Let's see if this would work. Now, is this of the right form? The question is this of the form f dashed x, f of x to the power of n with respect to x, maybe with some number there, like an a. Is it of that form? Well, this thing here, if I was to differentiate this in a function, I get 2x. So it's very, very like that indeed. So what I'm going to do is I'm going to try y is equal to x squared add 5 to one higher power, to the power of 4 as my answer. The reason to the power of 4 is because I know when I differentiate this, it would leave this, but with a power of 3. So what would dy by dx be in that case? Well, it would be you multiply by the power, which is 4, you differentiate inside the brackets, which would give me 2x, you keep the bracket as it is, x squared add 5 cubed. So dy by dx, therefore, would be equal to 8x, x squared add 5 to the power of 3. So therefore I know that differentiating this function gives me this, so integrating this function gives me that as the answer. But I don't want to integrate, well, if I did want to integrate 8x, x squared add 5 to the 3 with respect to x, I don't want to actually integrate that in the question. I want to integrate just one of these. So what I'm going to do is I'm going to leave the 8 in there, but I'm going to divide by 8, so I'm getting the integral I'm after. So what would this be? This would be an 8th and this thing here, x squared add 5 to the power of 4 plus a constant. And you can always check that you're right by actually differentiating this and getting the thing that you were started off with in the question. Okay, let's have a go at another one. Now, this is a fraction. So the first thing I'd like you to think, before you do anything, the first thing I'd like you to think is the top the differential of the bottom? So if the bottom, if our f of x was equal to 2 plus cot x cubed, is the top the exact differential? So let's try and work out the differential of the bottom. It would be, you'd bring down the 3, okay, you differentiate inside the brackets and you get cosec, in fact you get negative cosec squared x, and you keep the bracket as it is, but you'd reduce the power by 1. So the top is not the differential of the bottom, so it's not of the form f dashed x over f of x, and hence a logarithmic answer. It's not of this form, but that's the first thing I'd like you to check, but it's not of that form. Partial fractions isn't an option here because it's trigonometric, so what we're going to try is we're going to try and see if this is the ones we're just talking about. Is this, if I rewrote this of this form, the integral of cosec squared x 2 add cot x to the power of negative 3 with respect to x. Now, that could be thought of as of this form, f dashed x, f of x to the power of n. It does look of that form. Well, let's check if it's of that form. We said that if it looks a bit like that, we try y is equal to 2 add cot x to 1 higher power, so to the negative 2 as my answer, and let's see what we get. Well, let's give it a go. If we differentiate this here, what would you get? dy by dx. Well, you bring down the negative 2, so you'd multiply by negative 2, you differentiate inside the brackets, which would be negative cosec squared x, and you'd reduce this power by 1, so you'd have 2 plus cot x to the power of negative 3. And you'll see that when you simplify that, you actually do get 2 cosec squared x divided by 2 plus cot x cubed. Okay? Which is very like what we're looking for. So we're trying to integrate cosec squared x over 2 plus cot x cubed. If I stick a 2 in there, like that, so I know the integral of this is that, and I divide by that 2 to undo that, just sticking the 2 in there, I would get the answer as a half, and this answer here. So a half 2 plus cot x to the negative 2, plus your constant of integration, like that. Okay, so that's how I would get the next answer. Okay, just a few more. What about this one? I tried this one in the last video on integration of to get logarithmic answers, and I found this was not a logarithmic answer. I.e., I tried to see if this being f of x, if the top was the exact differential, and it wasn't. So having done that, and it's not partial fractions because it's got a square root, what if I rewrote this as 2x add 1, x squared add x add 5 to the negative a half with respect to x? Then it looks like it might be of this form, f dashed x, f of x to the power of n with respect to x. Because the differential of this thing here is 2x add 1, so it looks like it's of that form. Whenever I get it of that form, I'm going to try y is equal to this thing, x squared add x add 5, okay, to 1 higher power, so to the power of a half here. If I differentiate this, what would I get? Well, I'd bring down the half, so I'd have a half. I then differentiate this here, I'd get 2x add 1, and I'd keep the bracket as it was, x squared add x add 5 to the negative a half. And hence my dy by dx is equal to a half, and then 2x add 1 over the square root of x squared add x add 5, which is almost identical with what I'm trying to integrate. So if I'm trying to integrate 2x add 1 over the square root of x squared add x add 5, I know how to integrate half of this, which is this answer, so I'm going to stick a half in there, and to undo the sticking in a half, I'm going to multiply outside by 2. So if I'm trying to integrate this, the integral of a half of this thing is just this here, but keep your 2 there. So I'd have a 2 multiplied by this, so x squared add x add 5 to the power of a half plus your constant. Obviously you can check you're right by differentiating this thing here and getting this as your answer. Okay, now last one. This one is really quite a tricky one here, but let's do it anyway just to see how tricky they can actually get. Now looking at this, straight away I'd like you to think to yourself, well, it looks like it's of the form f dashed x, f of x to the power of n with respect to it. It looks kind of like that thing, okay? Although maybe, we might have to do a bit of adjustment, but it looks like it might be that thing. Now, if we let y is equal to sec to the power of one higher power, let's call it 5, be our guess at the answer, and we differentiate this, let's see what we get. Well, if you bring down the power of 5, you differentiate sec, which you get sec x tan x, and you reduce the power by 1. So you would have sec x to the power of 4 there. So you would get yourself 5, and you've got a sec x and a sec to the power of 4, and you've got a tan. So you would get 5 tan x sec x to the power of 5. That's your dy with the x. Now hopefully you can see that that isn't quite what we're looking for. We're looking for the 5, yeah, sure. We're looking for the tan x, yeah, we've got that. But we've got a sec to the power of 5 here. We want a sec to the power of 4. So I'm thinking maybe I've tried 1 too high power here. And the reason the power is an issue in this case is because when I differentiate sec, I get a sec tan. So although my power reduces by 1, it increases by 1 because of this here, so it doesn't change. So if I want a sec to the power of 4, maybe I should try my answer as y equals sec to the power of 4 and see what I get. So if y is sec to the power of 4, what would happen if I differentiate? You bring down the 4, you differentiate sec x, which is sec x tan x, and then you keep this sec x, but you'd have it to the power of 3. Now look, you've got 4 tan x, which is what you want, and you've got a sec x to the power of 4, which is what you want. So you've got the tan x sorted, the sec x to the power of 4 sorted, and you can just adjust the constant. The constant's not an issue for you. So we know that the integral of 4 tan x sec to the power of 4x with respect to x is going to equal this thing. It's going to equal sec to the power of 4x plus a constant. I don't want to integrate 4 tan x squared. I want to integrate 5. So what would I have to multiply this by to make it 5? Well, I would have to multiply it by 5 over 4, because the 4's would then cancel and I would get a 5 there. So the answer to this must be 5 over 4 sec to the power of 4x plus your constant of integration plus c, and you're done. Okay, so they're the examples I wanted to cover. Just to talk about a little quick summary here of what I want to do. These questions, they are always of the form, if you have something like f dashed x, f of x to the power of n with respect to x, something like that, you try y equals f of x to one higher power as your answer. You differentiate this and see what adjustment you've got to make. So this was the big idea here. Now, it links a little bit in with some things of this form. If you have an algebraic fraction and it's of the form, that form, you know straight away that the answer is the natural logarithm of f of x plus c. But sometimes you've got some fraction like this, which it's like this. It's f dashed x over f of x to the power of something, like over f of x to the power of n. It's something like that. Now that is of the form f dashed x, f of x to the power of n subtract, sorry, not n subtract 1, sorry, negative n with respect to x plus c. Not plus c, sorry, it's like that. Now, sometimes when you've got something that looks like this, your instant reaction is to think it's a logarithm. By all means, check it's a logarithm, but if on the bottom you've got a power of n, okay, I would rewrite it in this form here, and then use this standard result up here. So, examples where this came up, looking back at our examples where this came up, it came up in that type of one there, because I had an f dashed x and an f of x to the power of negative a half, and it worked out in that case. First of all, I thought it might be a log, but it wasn't a log. Okay, and it also came up in this case here. I had f dash x on the top, I had an f of x to the power of n on the bottom, and it came up in that case. So just to think about here, these integration by inspection usually come up in this case here, okay, but what it can also come up in this case here where you have a fraction where the function of x on the bottom is raised to a certain power. So that's one to think about, and to think about it at the same time as you're thinking whether it's a log or not. So there's a lot that has to go in your mind, but think through all the possibilities and see which is the appropriate answer. Okay, to check you understand all that, there's the work that you should do. Thanks very much for watching.